welcome to Climate Chat. I'm your host, Dan Miller, and today we have a special returning for the third time guest, René van Westen, who is one of the leading AMOC climate scientists out there doing tons of research. And we've covered a bunch of his papers in previous episodes, which are linked, by the way, in the video description, as well as actually the paper we'll be talking about today. And he has a new paper that's kind of exciting and scary at the same time, I would say. And so we're going to get into that, as well as some other very recent AMOC research, which actually complements the work that René has been doing. So René, welcome to Climate Chat. Great to have you
Yes,
here again.
thank you so. Yeah, thank you so much, Dan, for the third time. So I really enjoyed coming along. So that's great. Yeah, to catch up again.
So, by the way, before we get started, of course, please like and subscribe because we're trying to get this vital information. As you're going to see, this is information that's going to affect everyone on the planet in the coming decades, and and it's not getting much coverage at all in the mainstream press at all for what it deserves. But maybe just a very quick, very brief bio, like your academic background, and specifically what got you into studying AMOC.
Yeah, so I'm a postdoctoral researcher at Utrecht University in the Netherlands. And I'm on the project together with Henk Dijkstra, and we are figuring out what the probability is of an AMOC collapse within the 21st century. Because it's such a big system, it really shapes the present day climate, also for North America, but also for Europe. And we know that there is, of course, a risk of tipping, but is this like 1% or is this way higher? And it turns out over the past couple of years, we think that this risk is substantially higher than the previous assessment of the IPCC report.
That's right. And by the way, since this podcast is now going out on audio podcasts on Spotify and Apple Podcasts, all the streaming platforms, we might have some new guests that didn't watch the first two episodes. So maybe you could spend like half a minute or a minute telling us what the AMOC is.
Yes. So you can think about the AMOC as a big conveyor belt in the Atlantic Ocean. So we are only seeing the upper part of the conveyor belt, so the thing where you actually stand on, and that is flowing from south to north over the surface. And along its way, it is giving a lot of heat to the overhead atmosphere, and therefore the northern hemisphere is relatively warm, and especially Europe is getting heated quite a lot by this massive circulation system in the Atlantic Ocean. And eventually the circulation comes to around Greenland, and there it sinks into the deep sea and then returns as a cold, deep undercurrent at greater depth out of the Atlantic Ocean again. So you get like this whole conveyor belt image. And it is actually redistributing heat around the globe, and therefore it really shapes the climate even on the southern hemisphere, the northern hemisphere, but also the tropics.
And it's, by the way, stands for the Atlantic Meridional Overturning Circulation, which
exactly.
I don't know how many times you have to say that during
exactly.
week.
And yes, and also the good to mention that we're also going to specify that. So I often refer it to as the Gulf Stream. So a lot of people
in this particular context, right?
Yes, but actually, so that's more for science communication that I refer it to as the Gulf Stream. But the Gulf Stream is only a teeny tiny part of the AMOC. So therefore, it's already good to make this distinction because, like in one of our studies, we really made this distinction between the Gulf Stream and the AMOC.
And also to put a fine point on it, and we had discussions on this last year because there was this paper coming out saying the AMOC will not collapse because they were talking about the Gulf Stream, and the Gulf Stream is like wind-driven currents, right? So,
yeah.
So when we talk about AMOC collapse, we're not really talking about the Gulf Stream itself collapsing. Is that right?
Exactly. Yes. Exactly. Yeah.
But even though it's a very small part of this much bigger system. So that's something that I think there's some disinformation or a misunderstanding when it comes to that. So using that term Gulf Stream is a little bit dangerous.
Exactly.
Even though it is, it's what everyone's heard of and they haven't heard of AMOC. So
no, exactly. Yeah.
But they will be hearing about AMOC in the coming decades. That is for sure. Okay, so now that we got that out of the way, you have a new paper entitled Abrupt Gulf Stream Path Changes are a precursor to a collapse of the Atlantic Meridional Overturning Circulation. And that sounds rather ominous. And by the way, when you read the abstract is also quite ominous, but maybe tell us a little bit of what this research, what it was and what it tells us.
Yeah. So it's also maybe good to introduce this a little bit. So we have done these kind of simulations in the past in which we add fresh water to the North Atlantic Ocean in order to collapse the AMOC. So these are kind of idealized experiments because we just want to see the sensitivity of the AMOC. When will you reach your tipping point? And we do not include any climate change in those simulations, so that we have like a pure, very idealized AMOC collapse scenario. But that allows us to really like disentangle like all the feedbacks that are, such that we can actually monitor the system in very much detail. So we've done it in the past, but that was typically done with so-called standard climate models. And they have a relatively coarse resolution, so you can't actually resolve the Gulf Stream. So the Gulf Stream is like really spread out in those models. And what we did last year is that we also did such a simulation in which we add freshwater to the North Atlantic Ocean in a very high resolution climate bubble. So you're having like all the details of the Gulf Stream are in there, so you can actually look at the Gulf Stream interactions with the AMOC. So that was something that we already did, and we saw some things happening in the Gulf Stream, but we were like, yeah, we will do that in a follow-up study. So that was published last February, in which we looked at the Gulf Stream. And we know from theory is that if the Gulf Stream is getting weaker, the Gulf Stream may shift northwards. And what we now first did is look at the Gulf Stream behavior. And what we actually found is that it was also shifting northwards the weaker the AMOC gets. But there was like some kind of point for which the Gulf Stream really jumped northwards, about 200 kilometers in 2 years' time. And if you put that in perspective, that is really abrupt. Typical climate timescales are usually moving things like very slowly, but now we find this very abrupt jump, and it is actually what you can see in the lower right panel. So that is the Gulf Stream path at a certain position, and then you see really like this very striking difference within 2 years' time.
2 years' time.
In 2 years' time.
That's amazing. And then here, showed like, is this the northward shift here that we're looking at compared to here?
Yes. So that is like the on the upper left one, that is like the present day situation. And in the upper right one, so at your cursor now is above, that is like the new position after the shift.
And for our audio only listeners, we're looking at maps and graphs from the paper. One shows a Gulf Stream that's sort of flowing out from Cape Hatteras out to the east. And the other one, after the AMOC collapses, I guess, or about to collapse, it's significantly shifted upward. And then what is the lower right actually showing us here? This is all the position, right?
That is the position at a certain longitude. So that is to be specific, at the 70.5 west. And that is just looking at the latitude of the Gulf Stream at that location. And then you see a lot of variability, but then there is the shift.
And then an incredibly fast, amazing shift upward of the Gulf Stream, about 200 kilometers, I think. Is that right?
Yes. Yeah.
Wow.
And that is definitely significant if you also look at above the noise level. So it is about 5 standard deviation above the natural variability. Okay. So even CERN would label that as a significant finding.
But so, however, this is just a model, a simulation. So saying, wow, look what happens. I mean, that'd be interesting because it's a model, but you went further than that.
Yes. So what we also know is like the first part of this graph. So that's before the shift. There is also like a very small drift going northward. So in the same panel that you're now your cursor in, on the right one.
Okay.
The lower right, yes. So before that's also a shift. No, I'm really looking at the first part of the graph. So before the whole shift. Okay. Oh, you were in the correct panel. So this black graph that is going up also before the abrupt jump.
Mm-hmm.
So you go from around in model year 1, you're starting around 36 degrees north. And before the shift, that is around model year 390, you are reaching about 37 degrees north. So this part, that is also connected to AMOC weakening. And that is now very nice because like first you have AMOC weakening, and then you have the abrupt jump, and this abrupt jump happens before the tipping point.
Okay, of the AMOC clap, right?
Yes,
Okay.
in our model. But if we already can see some AMOC weakening, we would also expect some like a northward shifting
Right.
Gulf Stream path in, for example, in observations. And here is the problem with present day AMOC observations is that the total length of the time series is about 20 years. And it is, however, it is simply too short to already draw any conclusions whether it is weakening or not. There is a weakening trend, however, not significant.
By the way, speaking of that, but maybe you can clarify something, because in this graph, which is a model graph, it says model year 100, 200, 300, 400, 500, 600. So these years, these quote model years, are way, way longer than observational years that you're talking about when we and what we care about. We care about 20 years, 30 years. So why do model years, why are they so big compared to the what is supposed to be showing us, which is more of a real time kind of thing?
Yeah. So that is what we have this idealized setup. So that is that we add at a very slow rate some fresh water in the background, and we really want to see like what are the feedbacks of the system and what is like driven by other effects. And this last component that is very small in our simulation. So therefore, we can really say like the jump that we see with our simulation that is really related due to ocean dynamics that they behave differently. And if you would add like a very vast force into the system, you could also see these changes, but then it is very hard to attribute like what is now caused by ocean dynamics and what is now caused by the forcing. So therefore, we can now really make like a clear distinction between two of them. So this is really due to ocean dynamics and not by the forcing.
So in other words, you're kind of running your model in slow motion in
Exactly.
order to observe everything, and when you map it to, so tell us what happens now. You took a look at the real world, the real Gulf Stream.
Yes.
What have you learned about that?
Yeah. So if we would see like a northward shifting Gulf Stream in observations, that could indicate that the real AMOC is also slowing down. And that is something, the last part of the paper, it is in figure 6. And there we explored like, okay, now we have some model evidence. Is this also working for the real Gulf Stream? So we did the same thing. We looked at observations. And again, here in the lower right panel, there you can see actually the Gulf Stream path at this certain location. And maybe it is a little bit hard to see it from the monthly average time series, but if you convert it to a yearly average time series and determine the trend, there it is significantly shifting northward over this 30-year period that is available to us. And that suggests that the present day AMOC is indeed weakening.
Which
And
we
that the
also
Gulf
know is
Stream.
happening just from other measurements, right? I mean,
Yeah. So, well, we see it, but it is not significant yet. So we are trying to look at also some indirect evidence, and this could be like a potential candidate for, okay, we have some observational time series. It is only 20 years long, but here we have also some like further evidence that the present day AMOC is very likely weakening. And that is also very nicely connected to the study that was published last week or the week before.
Right, that we're going to also talk about, right?
Yeah.
So, in fact, that's right here. Wait, is that right? Or is that this one? Observational constraints project a 50% AMOC weakening by the end of this century.
No, it's the other one then.
Oh, what other one then? Did I have the wrong one?
I sent 2 links to you.
Oh, okay. I'm sorry. I might miss it. Just tell me.
It was I think I can simply look it up.
I thought it was that one. That was the one I read. But let me quickly. I don't think this is not messing up.
It's called meridional consistent decline in the observed western boundary contribution.
Here we go. Wow. Okay, the second one. Okay, here we go. I'll pull it up right here, and I have to verify I'm a human first.
That's always good to do.
And
yes,
there we go. Okay.
So this was published the week before, and what the authors actually did is they looked at different kind of sections. I think if you go to figure 1 in this paper, so there are like different measurement stations placed in the Atlantic Ocean. So you have the famous rapid line. So it's here in the upper panel. So there's the green curve, the green dashed line over here. So this is the famous rapid curve, and we have measurements since April 2004. But the measurements are too short to draw any conclusions yet. But there is some weakening that's already being observed, about a 5% decline per decade. But we also have other measurement stations in place, and those are the other colors. So there's the MOVE array, it's called the line W array, and the rapid Scottian array. And those, so they looked at greater depth and looked at the AMOC strength along those smaller sections as well. So they are plotted here in panel B, C, D, and E. So you can see that they show some trends, and they are significant.
Yeah. Okay.
And what is now very nice with this paper is that this weakening trend, so the lines go up because it's actually negative. So they're looking at the southward flowing branch from the AMOC. So it's the thing that we don't see. It is way below the surface. But it is weakening also over there, and it is very consistent. So this really shows like a very robust response in their study of a weakening from observations. But why don't we then see that also for the full arrays? Well, there is some compensation also in the east. So things in the west, they mainly move southward, but there is also some contribution in the east that slightly moves northward, and that offsets the trends, and hence, therefore, it is not significant. But this really is from some very strong observational evidence that indeed the present day AMOC is weakening.
Right. And then, by the way, there was the other study that just came out that I just popped up there. I assume you know about this one as well, where they just said, hey, there's all these models. Some say it's weakening, some say it's not really weakening, but let's see which ones are accurate models. And they applied sort of filters to find out which models are the most accurate. And then when you just choose those models, it says, oh no, the AMOC is going to weaken by 50% by the end of the century with very high probability, I guess, according to those models. And that also fits into this whole discussion as well, right?
Yeah, exactly. Yeah. So we know that climate models have model biases. That is well known. And like what is a very persistent climate model bias is that the AMOC is way too stable. So that means if you add a forcing, for example, fresh water or climate change, the AMOC will probably slow down. So that is quite consistent among the different climate models. But if you take the multi-model mean, it shows about a weakening of 30%. So that is still substantial, not in CMAP6 terms, but that is still, you can still say that is a considerable decline in the upcoming decades. But probably the climate models are underestimating the weakening. So you need to correct for them. And we know why this is the case, because their freshwater,
mixing,
the mixing, the differences where the salinity is. So the salinity gradients, the temperature gradients, they are a little bit off in the Atlantic Ocean. You still get like a reasonable AMOC strength. So it is very close to observations, but its sensitivity is off. And now they are correcting for that. And if you do so, you're getting a proper or a more realistic decline, probably, compared to observations. So the real AMOC is, of course, quite sensitive. So you would also expect more decline. And of course, the worrying part of this study is that if we are having like an AMOC decline of about 50%, that also means that we are getting closer to the tipping point.
Well, we don't know. But by the way, I have to say, first, Jim Hansen said all of this years ago, that he said these models are mixing. And I actually looked into it after he wrote about this, and I checked this out, and he was right. And this was years ago. So now we're getting, but he was just saying that as part of some other study or as part of the communications he does. It wasn't like a specific study on that particular point. He just mentioned it. And it's kind of, and now the studies coming out confirming what he said. So we should be listening to what Jim Hansen says here. anyway, I'm sorry. So let's keep going on that. So,
Yeah, no,
um,
but
well,
I
no,
think that's
I'm sorry. My
oh yeah.
question was 50%. What do we know about, it's weakening? We measure it weakening. Your studies are showing this, and all we have all this data that it's weakening. This particular study says we're going to hit 50% by the end of the century. Where do we think the tipping point is? Because it is a self-reinforcing system. So you go
That
down a certain amount and then it just drops off a rock, right? And then that's when you have the tipping point.
Yeah, so and that is the problem that we are now facing, and that is the very big question because people want to know like when will we hit the tipping point? So we tried to address that in a study from last August, but then we're still working with these flawed models. So these biased models, so they're probably also underestimating the risk of tipping point. But then we found like the risk that we cross the tipping point is around 2060 to say under an intermediate climate change scenario. So that's about 3 degrees warming by 2100. But of course, that could be later, but that could also be sooner because there is also a huge uncertainty band.
Right.
And this, and of course, what we want to communicate is like, hey, the AMOC will collapse by that year, maybe in autumn, preferably like on a Wednesday. That would be, of course, great
3 o'clock.
maybe it's also we can indicate before Wednesday, before or after lunch, but that is something we can't do yet. And therefore we're trying to find also indirect indicators like early warning indicators that can tell us like something more information and preferably like some years ahead. And that is also what we tried with this Gulf Stream paper, is that we found this abrupt shift. It's a very spiky signal. So it goes north 200 kilometers in 2 years' time. So that is something we can clearly observe with satellite measurements. And if that would happen, for example, with the Gulf Stream, if we measure that maybe in the upcoming decade, like, hey, the Gulf Stream is now shifting northward quite drastically, that could then be like an early signal, like, hey, we are now very close to the tipping point of the real AMOC.
And now this is time now to sell your home in Norway.
Yeah, exactly.
And get out quick. Wow. All right. Well, we're going to get to that, the impacts, in a little while. So we have all of this, your studies and your recent study, this other one that we just looked into that you mentioned, and then of course the other one I mentioned. All of this is coming together. What would, I don't know, someone asks you just from a practical point of view, what's the probability that we're going to, and we have to also talk about this, like, what does it even mean to hit the tipping point? Because that doesn't mean everything changes right away.
No.
But to hit the point of no return, where doesn't matter what we do anymore, it's still going to continue on its path. If I ask you, what's that probability of hitting that around mid-century?
Yeah.
Can you give an answer to that, or like or a range of probabilities?
Yeah. So I think this is a very good and a very valid question, and also that we can explore a little bit more. Like, if you hit the tipping point, we will not be like in a day after tomorrow scenario that in 1 week time whole Norway will freeze over. So I'm very glad to clarify that. But first, coming to the probability. So according to our study from last August, so we found that hitting the tipping point somewhere in the 21st century was about 57% under an intermediate scenario.
Mm-hmm.
So that is more than 50%. So that you could say like that is a substantial risk. Mm-hmm. If you would then consider a very high emission scenario, so that is like 5 degrees warming, so that is not a realistic scenario, but then it gives also like some high end indication, then it would be about 90%.
But you say that's 5 degrees by 2100. That's what you mean.
Yes.
When you say 5. And then what is the temperature assumption for the intermediate by the end of the century?
Yeah, 3? So that's about 3 degrees. So that is our current
Which,
best
of course,
estimate.
Is catastrophic all on its own. You don't even need AMOC collapse on top of it, but then you're still going to get it. But how does that? Well, I'm confused. How does that jive with the fact of all this discussion from Hansen and you and everybody that we could be seeing a tipping point around 2050? And 2050 is not going to be impacted by 5 versus 3. It's going to be impacted by 2.5, because that's where we're headed next next decade. So
Yeah, so of course, like all the emission scenario pathways, they are like still a little bit the same around this time. But in the upcoming decades, like up to 2050, like this intermediate scenario and this high emission scenario, they are more or less kind of the same. But then after 2050, after the midpoint of the century, then they are starting to deviate. So the intermediate scenario really starts to levels off, while the high emission scenario still continues to rise.
yeah, I know,
And
but if we tip in 2050, we tipped. Now it might take longer to collapse, but we've tipped, and
yeah,
the difference for that, the 5 versus 3, as you just mentioned, is very little between now and 2050.
yeah,
So
yeah.
how
So
does
that's
that? So I'm confused about that.
well. So if you look at the total risk, so that is like if you just look at all the models, whether they do show a tipping point or whether they cross a tipping point, to say so. It's about 90% for the high emission scenario, and that is quite lower. It's 57% for the intermediate scenario. So
Mhm.
there you can really see some striking differences. But if you take the multi-model mean, there is like hardly any differences in the tipping time estimate.
Yeah, but do you think we could? Well, I guess I had two questions. Like, what do you think the probability of crossing the tipping point around 2050, let's say 2040 to 2060,
Yeah.
versus 2080 to 2100? You know, what do you maybe give different
Yes.
numbers for those
So
two?
yeah. Okay. So I get you. So I was so the figure that before 2100, that is what I know by heart. But around 2050, I don't know that. So then I need to look it up for my own study.
But
We
a
can
lot of people
actually,
are. I mean, lots of people are saying that that's the time frame.
yeah. So that is, yeah.
I'm
So
storing.
exactly. So from our multi-model mean, so that is around 50%. That is, so I think it is less than 50% before 2050.
Mm-hmm.
But of course, if we are keep on increasing our emissions, then of course this could be even sooner.
Mm-hmm.
And then also keep in mind with this new study that showed more AMOC weakening under climate change, so that could also, of course, increase this likelihood of reaching the tipping point, so the point of no return.
Mm-hmm.
So it really depends, of course, that we are working with climate models that have biases, so that make also these kind of estimates very hard to do.
And I think one thing I want to sort of ask you a strange question, because when we talk about probabilities from a scientific paper point of view, and you want to be 95% certain of them and everything like that, and there's the old saying that climate scientists are conservative in the opposite way that a risk manager is conservative, because you're trying to there's type 1 versus type 2 errors and all that kind of thing. So, but if you were an airline pilot and you had a gauge on your plane, AMOC, or something, and it turned out if the AMOC starts to shut down, your plane is going to crash. Like,
Yeah.
and in order to avoid this happening, you have to declare Mayday and land immediately. Like, what would you be doing even today?
Yeah, I really know. I think that's a very valid question. Like, would you go in that plane if you know it's like a risk of 50%? Well,
But you're the
probably
pilot
not.
in charge. Are you declaring Mayday right now, just from the probabilities you see before you?
I think so. And because it's not like a low risk, high impact scenario. I would not label it as a substantial risk.
It's a
With still
high risk, high impact scenario. It's the worst
yeah.
kind.
If we are not doing anything at the moment,
Which
but
we're
we
not.
are no, and we're still following a intermediate emission pathway with a still considerable risk. So if we are indeed lowering our emissions very rapidly in the upcoming years, then of course there is still then probably this then it's very likely that this probability goes down. So that is something good. That is also something we found from our study. If you cut your emissions, the probability goes down quite a lot. So that, of course, gives us some hope, but we're currently not following that path.
And we're not following that path, and the probabilities here are so outlandish compared to any other risk we would accept. An airplane crashing, if you had a 0.1% risk of something going wrong, you declare emergency. You're talking about 50% chance of crashing.
Exactly. Yeah.
And that's imagine 50% chance your house is going to burn down this year. I mean,
No,
insane risk for
nobody would
whatever.
would give you like any insurance for your house.
No
That
one
is
would give you
no,
any insurance. So let's
no, and
talk
I think
about. You mentioned that hey, we could get off of the high emissions pathway, and there are signs that we're. Well, I guess the good news is there's signs that we're not on the RCP 8.5 quote worst case emissions pathway, but we are on the worst case 8.5 climate forcing pathway. The forcings are more than we assumed for a given set of
yeah.
emissions. And so that's actually what matters for the AMOC, I assume. So we
Yeah,
are on
so
the
of
worst
course,
path for that right now.
yeah, and in some sense, yes, there are of course a lot of developments going on. So also in Europe, if you also look, for example, at the green power production in China, that is also skyrocketing. So
Oh,
there are of course some good signs, but the question is, are they fast enough, and are they in time to really, yeah, steer us off course, and that we hopefully see these kind of radiative forcing pathways that they will go down quite rapidly.
well, they don't go
Uh,
down; they just stop going up, right? I mean, you stop
I
emitting; it doesn't lower temperatures. It just, if you're
no, no,
really
no.
lucky, it stops temperatures from going up. But that's not anytime soon. I mean, that's not even in good case scenarios, 2070 maybe for hitting
They
net
have,
zero, right?
they
And
have
and
something
and
like
there
that.
you're sort of already past this 2050 time for the AMOC to collapse. But let's talk about another thing. Speaking of that, we just had Doug McMartin on last week from Cornell, and he's an SRM, a solar sunlight reflection methods, solar geoengineering expert. And he did a paper which we didn't cover last week, but we covered on his previous interview, where he showed that using SRM can actually slow or prevent the AMOC from collapsing if you deploy it correctly. So my question for you, have you looked at that kind of research? What are your thoughts on SRM versus just cutting emissions?
Yeah, so people are now really thinking about it, and scientists as well. So, can we deploy it? Is it a good idea to deploy it? Because maybe if you are adding like all those aerosols in the upper atmosphere, maybe you're also then really changing like weather patterns or rain seasons or whatsoever. But I've seen those papers. I'm not an expert on that, but I have seen some studies there where you can of course slow down the AMOC or also prevent it from collapsing. So you could think about that. Would that be an option to explore? And also, what you already mentioned before is like 3 degrees warming is already very bad news for humanity because we see a lot of sea level rise, loss of biodiversity, more people are exposed to heat waves, higher sea levels. So this list goes on and on and on. So that could already be enough motivation to implement these kind of techniques. But that we're still exploring in very high detail, like, is this a good thing to consider? And then you can also consider, of course, the other effects, such as can we prevent uh, tipping elements to go off? Maybe it can buy us some time so that we can really fix the planet and then hopefully eventually remove again this SRM techniques.
Well, but you just mentioned that one of the quote risks of SRM, it could change weather patterns. What will let's talk about that. What will an AMOC collapse do to weather patterns?
Well, quite a lot.
The
So if
mother of
you,
all, I call it the mother of all tipping points, by the way.
yeah, so the AMOX, of course, is really modulating or really shaping the planetary heat budget, and therefore, if it collapses, it also has both influences on the global south, but also on the global north. So if you just zoom out and look at the global perspective, what you would see on average is a cooling of the northern hemisphere and a heating of the southern hemisphere, because usually the AMOC is taking heat from the global south and dumps this in the global north. And if you stop this process, like all this heat will stay in the global south, and therefore you see more heating. And the northern hemisphere, on average, sees net cooling. And especially if you look where the cooling is the most pronounced, this is near northwestern Europe. So there you can see some spectacular cooling. It really depends on the amount of cooling, so the amount of AMOC reduction, but also on the amount of global warming, because they are like in opposite directions.
Right.
If So it's quite kind of subtle where you have this boundary where you can see net cooling or where you simply have net warming. But mainly northwest.
Scandinavia is out of. I mean, from what I heard, in wintertime, cooling is. We're talking about going like 2, 3 degrees warmer, global warming. I understand that, like in Norway and those kind of places in winter, it's like -10, -20 Celsius cooling. It's not a little bit more. It's crazy, right? Isn't that insane
It's
amount of cooling?
Yes, in some scenarios it can be quite substantial. Then you're talking about these kind of figures. But if the warming is like too much, then you would see like only like a few degrees cooling. So it really depends on the global warming level.
Yeah.
But also the UK, Ireland, they can also see some
Oh yeah.
substantial cooling, and as well as for Iceland.
Yeah.
So that definitely different regions are impacted under such a scenario. But for temperature, it's a little bit hard because you have like these things that go in opposite directions. But we can also look, for example, at precipitation and evaporation. And what you see is that also the AMOC brings a lot of moisture to northwestern Europe, also to other parts of Europe. And when the AMOC shuts down, you will receive less precipitation. And especially during your summer months, so from spring to summer and also to late summer, you will receive on average less precipitation. And also in combination with warmer temperatures, you can expect even more drying during that season. So for Europe, you get like a very strange climate now. So first you will go maybe into a colder winter with more intense winter storms. Also very large day-to-day temperature changes due to these winter storms. So like on one day it's below the freezing point, the very next day it is above the freezing point, and it again goes on and on. And then you finally are going into spring or summer, and then you have very dry conditions.
Right.
So also something from a national perspective, like on food security, this can be quite problematic.
Yeah, I saw one study long ago, actually, when I first started looking at AMOC, that was country specific for the UK, and they said AMOC collapse would lead to a 70% reduction in arable land in the UK. So that's just like one example. Now, you mentioned it's lower precipitation. My understanding, we had Matthew England on a long time ago talking about this, and it's like a foot less of rain across the entire, on average. I mean, across the entire northern hemisphere, not just Europe, but
No,
it really affects because it's bringing all this moisture up from the heat is bringing hot. Think of heat as water evaporation, and that gets into the atmosphere and it rains, and now you cooled all of that off, and now you have less rain across the
yeah,
entire area. And there's a lot more land in the northern hemisphere than the southern hemisphere.
exactly.
So you're not making up for it in the southern hemisphere.
No, yeah. So you definitely have some very drastic changes. And also, it's not something related to weather patterns, but on top of that, you also have like additional sea level rise in the North Atlantic Ocean.
Right?
And especially as low-lying regions such as the Netherlands, where I'm located in, this can also be quite considerable again. So then we're talking about 50 centimeters additional sea level rise on top of the current projections if the AMOC were to collapse.
I thought that
So
was mostly across the northern North America East Coast. I thought that's
yeah,
where
so
most of
there
that
you
was.
yeah, so there you see also a lot of sea level rise as well. I don't know the
Yeah.
figures by heart. So we
A
have
couple of
a
feet, 2 feet or so, or
Yeah,
uh,
something like that. Yeah, in that range. So that is again quite considerable also for the North American coastline along the Atlantic side. So you see like this whole shift of like what we have nowadays with our present day climate. You can really see like big fingerprints in all different kind of quantities. And if you go, for example, to the tropics, there you see the rain belts. They are typically shifting southward. So it is not only Europe and North America are affected. No, also the tropics. And there you see sometimes for the Amazon rainforest, there the dry season becomes the wet season, and the wet season becomes the dry season. So again, tons of
an
shifts
Indian
across the globe.
monsoon shifting, all the things that people worry about if you do SRM happen like in spades if the MOC collapses, right?
No, yeah. So therefore, we want to avoid such a scenario at all costs because the climate impacts are probably very, very bad for humanity. Also, from a societal point perspective, for biodiversity, for a lot of ecosystems which are quite vulnerable. So this is simply not very good news if we would, trigger such an event.
But our choices, our tools available to us to prevent this event are, I guess, three things. One is to reduce our emissions, to do carbon removal, to cool it even more, and SRM. But the first two happen, their response time is many decades. You start reducing emission, you don't even know you notice it happened
Yeah,
until way later, right? In fact, it doesn't actually reduce temperatures. It only slows down the rate of increase
yeah,
until you finally get to zero, which we're not going to do for a long time.
exactly.
That's why I think SRM, which happens the next year, you do it.
No.
It starts cooling right away.
It's
So if you're in an emergency situation, I don't know what else even comes close to having the potential for
yeah.
having an impact on the AMOC.
No, that would be hard. That would be, of course, like a very hard break on the climate system if it really, just flies off. Then maybe people really want to implement those kind of things, and this can, of course, already be implemented. For example, a lot of people are also having this debate because do we need to research that? Because like a rogue state, so to say, they could say like, oh, we're going to implement solar radiation management by our own, so they cool the planet as a whole,
Mhm.
just to lower the temperatures directly. Yeah, so we want to explore, of course, first those kind of effects, but the calls in science, they become louder and louder to really,
Are you looking into, is that
investigate.
on your research agenda or other just
No,
folks? Okay.
no, but I know my direct colleagues are looking into this.
Okay, very good. So let me get back to this is a question that comes from Tom Harris via Blue Sky, actually, with a little bit like the previous one, but said, could you ask Renee about the climate changes we are likely to see as the AMOC weakens? We have a fair idea what happens after collapse from his earlier papers, but what can we expect to say in, say, 10 to 20 years time as it drops to, say, 50% in strength by 2100?
Yeah,
Sea level rise, winter temps, etc. Rain.
yeah. So that is something, I think that's a very fair question, and this is something what we try to avoid with the earlier papers, because it when you reach the tipping point and how fast the AMOC will weaken, so that really, like this timing, that is kind of problematic, because it really varies per model, it really varies per emission pathway. So therefore you need to consider like all those different kind of effects, and therefore we took like a shortcut, so to say, is that we just looked at the end state of the whole system. Then we know like, okay, this is like a future scenario we found in our climate model simulations. So if you are on that kind of path, you can expect such a future. But when, we deliberately left that out because it's very hard to address. But again, if you were to have like some kind of estimate, it also depends on the global warming rate and also how fast the AMOC goes down and whether you will reach a tipping point, yes or no. So
Mm-hmm.
if the AMOC weakening is not that substantial, you can imagine that climate change will be the dominant signal showing up. So therefore, you can still expect warming. You can still expect drying. So that is like the standard IPCC projection. But if, of course, AMOC weakening becomes more pronounced, such as the 50% signal, what you could see, for example, is that maybe in the upcoming decade or decades, you would see for Europe that the warming trend that we see nowadays, that we see from direct observations from weather stations and that kind of stuff, that they will first show below average warming and
Slow
maybe
down.
also then even slow down and maybe even switch sign and then they show cooling. But again, that depends on the warming rates and how fast AMO goes down.
So all the deniers will say, "Look, Europe's cooling. See, all that the climate change is bunk." But of course, it's an alarm bell going off that you have to
Yeah.
really worry
So
about it. Yeah.
so if we would see that, for example, in the upcoming decades, or maybe the decades that Europe starts to show below average warming, that would be also a very clear sign that the AMOC is weakening and that its signal becomes more pronounced than the global warming signal.
And we'd also see big impacts on rainfall and things like that, even as it weakens, right? I mean,
Yeah, of course, like any amount of weakening will also impact these kind of patterns. And if AMOC weakening becomes even more pronounced, then also the shifts become larger.
now one thing I heard about that was that I think Jim Hansen talked about is when this happens, Europe gets cold and all of a sudden. So now, right now, we have the temperature differential between the equator and the North Pole is dropping, and that's making the jet stream wavy and all that kind of stuff. But now, all of a sudden, you're going in the Atlantic, you're going to have this really cold
Yeah.
difference between the equator, not in the North Pole, but the equator in Europe and Greenland, and that's going to drive storms like we've never seen before, according to Jim, the storms of our grandchildren, which was actually related to a different phenomenon, but I think sort of the same idea.
No, yeah, and that was also something we also analyzed in the paper also from last year. So we looked near Europe, like what are the storm tracks doing over there during winter time, and you're getting like a very strong equatorial to North Pole temperature gradient over your Atlantic Ocean. So first of all, your jet becomes stronger, and secondly, also your winter storms become more pronounced. And then you also having like there is still a lot of warm air setting in the south. And if you have these kind of storms, they bring up a lot of warm air then to northwestern Europe. So then you're getting these very strong day-to-day temperature jumps, sometimes up to 20 degrees Celsius in 24 hours.
Wow. One other big change that Jim Hansen talked about again years ago about AMOC collapse was that you're sending all this warm water to Europe, and now, of course, the AMOC collapse that shuts off. That warm water is hanging around the southern hemisphere, hanging around Antarctica, and accelerating the rate of Antarctic ice melt, leading to what he put it, multi-meter sea level rise in 100 years. So not thousands of years, but actually quite quickly, and that wipes out every coastal city and multi-meter 10 plus feet of sea level rise around the end of the century. So what are your thoughts on that?
Yeah, so this is also a very good question. So that is like what will interacting tipping elements do in the climate system? Because some people also say to me like, oh, can we also save Greenland now because you are cooling the northern hemisphere? So maybe this will save the Greenland ice sheet because you're cooling now the entire northern hemisphere. So that is one way to put it. But that is something that we can't do nowadays with our climate models because that requires a lot of computational resources, and that is very hard to tackle. Like, okay, your AMOC shuts down. What will happen with the Antarctic ice sheet? What will happen with the Greenland ice sheet? And also, for example, the Amazon rainforest. And that is now there are a lot of groups that are focusing on that, but usually they use like very simple or idealized models to say something about these kind of interactions. So a colleague of mine also investigated like the effects of the Antarctic ice sheet, the AMOC, and the Greenland ice sheet. And there are some cases in which you can save the AMOC by melting the entire or melting the Antarctic ice sheet. But still, the AMOC
doesn't sound like a good trade-off.
No, it's not. It's not a trade-off. So usually, what you see, if a tipping element goes, it's usually bad news. It really drives your whole climate system in some kind of chaos. And of course, you get like a new balance and how a future world would look like. That is of course quite challenging. But I have also so you're calling you also mentioned Matthew England. So we have now an ongoing collaboration with a group from New Zealand and Australia, in which we are going to answer that question. So what will happen with Antarctica if the AMOC is going to collapse?
Very good. So we'll have to have you back to talk about that as well. So let me, before we move on to our questions from our co-mods and from the YouTube audience, just one last question. So the mainstream, this is, I always feel strange doing these kind of interviews because we're talking about the most important things in the world. Now, yes, I mean, what's happening in Iran and Trump and everything, it gets all the news all the time. Price of gas, everything like that seems so important to everyone, which it is important right now. But this is forever, and this is like the whole world, and very dramatic, very negative impacts. We didn't really spend enough time maybe going through all the negative impacts of an AMOC collapse. Yet the mainstream coverage isn't really there, including really mainstream climate science, I would say, like IPCC. So when do you think that's going to change? First of all, when do you think maybe mainstream science, IPCC, for example, will talk about near-term AMOC collapse as not just this unlikely event, which is what it says now in the IPCC, and make it an urgent thing.
No, yeah. So I think the assessment from the last IPCC report was not like, oh, we or they based that on climate models. They didn't show any AMOC collapse. And then they also assessed it as a very unlikely to happen within the 21st century. But now we have much more knowledge since 2021, like how fast is an AMOC collapse? It's typically about 100 years time. So if you want to say something about an AMOC collapse before 2100 or like really reaching a collapse state, that is not very likely. So it happens like its most impact is happening after 2100. But we can of course reach the tipping point, so trigger the point of no return already before 2100.
Maybe already now, right? Maybe we
Yeah,
have
so that
already?
could. There are a few papers they already saying that we already crossed the tipping point.
Yeah.
So that can of course be like one scenario. So that we didn't have any clue how to look at these kind of projections. So whether we already crossed the tipping point, and we also have now a much better like kind of grip what the impacts are, because there are a lot of studies from international colleagues, also from our group, that we now lay out like some kind of future scenarios, like this is what a future world could look like if the AMOC were to collapse in combination with climate change. And that was also something that was only limited studied previously, or it was studied, but with relatively coarse climate models. So really the generations before the current modern complex climate models. So they give us some indication, but quite limited information. So now we can do it in a much more sophisticated way. So we're getting better to that. And I think if you look at the main like sources or the main publications from the past few years, there is this tendency that probably or that there is a urgent call to reassess what the probability is by the IPCC report. So they probably are going to do that. And it's also good to say that this is still a very active area of research. So there are also a lot of groups, they say like, hey, there are also some stabilizing factors, such as the Baker et al. Paper, so from 2025, which was published in Nature. So they say like there can be some remote forcings that can stabilize the AMOC, such as the Southern Ocean winds. So that of course is also, it is not like already settled. No, we see there is new evidence, there's gathering evidence that the AMOC is very likely weakening. There is now more evidence that the AMOC can reach its tipping point under 21st century climate change. And therefore, this risk that was assessed as very low, that this will probably, or I think what the IPCC report will do is that they are going to reassess that and they will give it some likelihood again. But I don't think they are going to say that it is very unlikely.
Okay,
So, but of
how about the mainstream press? Do you get interviews from mainstream press about AMOC?
I got a lot of interviews with the mainstream AMOC, so I'm really happy about the coverage.
Okay.
But sometimes I also still speak with reporters, and they're like, "Oh, this just came across my deck. I've never heard about the AMOC." So in some areas, some reporters are very familiar with this topic. I do quite frequently interviews, also with you, Dan. So thank you again for the invitation. But yeah, also some reporters are not catching up on this. So I think it really depends per platform.
Okay. Well, I actually, you reminded me of a question I accidentally skipped. So maybe we'll end with this one. When we say AMOC collapse, and people think, okay, it was this way, and then boom, and now Norway's frozen in England, etc. But that's not what you mentioned. It actually something that occurs over maybe around 100 years. I heard the number 30 to 100 years was the estimate I got from Peter Diblerson. But
yeah.
But so maybe no more. But tell us what it means. Let's just set the scenario.
Yeah.
The AMOC, we hit the tipping point. Usually in the rear view mirror, we find out 2050. In the year 2050, we hit the tipping point. What does that mean in terms of when we feel the real impacts of AMOC collapse?
Yeah. So I think this is a very good point to end with. So thank you for that opportunity. So of course, what we will see or in the upcoming 30 years or 25 years as remaining till 2050, we would see some AMOC weakening. So that is always preceded before reaching a tipping point. So we already would see some weakening. And eventually, if we are before the tipping point and we say like we are cutting our emissions all the way to zero, maybe we could save the AMOC so then it recovers. But if we are then reaching the tipping point, no matter what we do, it will continue to decline. So even if we cut all our emissions, we are going back to pre-industrial levels of CO2 and methane and that kind of stuff. So temperatures are dropping then the AMOC will collapse due to its self-perpetuating feedbacks. It's like a snowball effect. And this transition, so you could say it's like the tipping time transition, that takes about 50 to 100 years. It also depends per model. But then you could see that these kind of effects of an AMOC collapse, they become even more and more pronounced. AMOC weakening is also giving its impacts, but if the AMOC really goes down, those kind of signals, those kind of climate shifts, they become larger and larger. And therefore, it is not happening like the day after tomorrow within 1 week. No, it is about 1 century as a whole.
Okay, good. Thank you for that. So let's move to Stacy here. And wait, hold on a second. Here we go. Hey, welcome, Stacy.
Hey,
Hey, good to see you.
Renee.
Hi.
Well, my first big question is
You can move your mic a little closer because.
Oh, sure. And actually, Dan.
I know I heard about mine, but I moved it a little closer. Am I hearing okay or what?
There's such a differential between the two of you.
Okay.
I don't know. Can you hear it between Renee and me as well?
I hear you as being quieter, so maybe Renee is hot mic, but that
Oh.
doesn't matter at this point. So let's
Okay.
keep going.
Yeah. Sorry, everyone. Thanks for hanging in there. So I wanted to know how the first year of being a dad has been.
Oh, it's well, he turns 1 in 2 days time, so it's a nice anniversary. Well, it has been a hell of a ride.
You've been very busy publishing though as well.
Oh, I know. So I've done tons of stuff, also being a dad and trying to be a supportive partner, and also spending a lot of time. So he's called Tias. So spending a lot of time. So it's been also quite challenging, but it's also still I still really love my job doing science. So it's also me juggling around quite a lot.
You have to update your university webpage. You don't have any of your papers since 2024 on there.
Oh,
So,
thank you so much. I will update
You
that.
can always look up Google Scholar though, and you can always find the latest
yeah,
stuff
right.
there.
But I mean, have one of your TAs get on that or something.
Yeah, exactly.
So I've been chuckling a bit over here. You had a really good one asking about when you're asked about when this planetary system will stop, and trying to estimate that. That is, I can't believe that we're even like that it's a possibility, let alone in years, in our lifetimes, and we're not doing anything about it. It's really tough.
Do you have any other questions? We're going to go to Leon and Eli, then go back to the YouTube.
Yeah, the only other thing is, what do you AMOC people like? Do you and Ramsdorf hang out? Like, is there a club or something? Like seriously, because you guys are all this is a hot topic now, and I don't know if.
Yes, so a lot of people are working on that, so it's really a hot topic. And now I have really like a good contact with Stephen Ramsdorf. So also on the big major conferences, I often speak to him. But we also sometimes, if new studies come out, he's often also interviewed, and then we can also sometimes like, hey, I found this interesting study. What do you think about that? So yeah, I know Stephen quite well.
Excellent. Okay, yeah, I have some questions from YouTube, so make the rounds.
Let's see, Leon first here, I guess. Sorry, we did that twice. Leon, welcome. Hi.
Hi, René. Great to have you.
Hi. Thank you.
We're very close to each other. I'm in
Again.
and thank you very much for your research and also for making it open source and for making all the other graphs easily available in the supplements. I think many scientists around the world can learn from that. And I was quite surprised that even the recent paper by Ramstorff was celebrated as a 15-year anniversary of Nature climate journal, and it wasn't even open source. So thank you very much for making this crucial science available to everyone. And a question I have: you mentioned that the different scenarios, the emissions are the same for the near term, and of course or almost the same, and of course the concentrations of the greenhouse gases are almost identical, because those are cumulative. But a very important forcing for the AMOC, according to other studies, are aerosols. Have you looked at that part yet? Like how different scenarios, how aerosols in different scenarios impact the AMOC or the Gulf Stream, or how that would relate to your work?
Yeah, so that's a very good question. So definitely aerosols do influence the AMOC. So a lot of people have also looked at that, changing aerosol concentrations, and then you can also get different responses. We have a preprint out in which we are only forcing like CO2, and then we can look what the responses are. And although, yes, we definitely agree that aerosols are important, I think the greenhouse gas forcing is more dominant. Also looking at the projections of aerosols, emissions, and that kind of stuff. But that is still under review, the paper, so we need to wait for that.
Yeah, it will be interesting to see how, of course, the shipping emission changes, and also the resulting increase in absorbed solar radiation, both in the North Atlantic and in the North Pacific, which is about 4 watts per square meter. How that could impact, and of course, the resulting imbalance, how it could impact
that can be quite substantial. And that is also something we saw in 2023 and 2024, that there is, of course, tons of heating. So we had like this whole North American basin, like especially upper 100 meter, which was very warm temperatures. Probably it was also due to like less mixing, due to less wind input, but also the aerosols can be definitely a big influence on that.
Yeah. Do you see that back in the also in the Gulf Stream, for example, if you have a very high surface temperature, either in North Pacific or in North Atlantic, can you see that fingerprint in the North Atlantic, in the Gulf Stream?
Yeah, I'm not entirely sure. I didn't look at that those connections.
Okay. Yeah, those are very short term, of course. Okay. Thank you very much.
Let's bring hold on, let's bring Eli in. Hey, Eli, welcome.
Hi, thanks, Dan. So, René, you've almost certainly seen the paper about 3 weeks ago by Neon and Rockstrom et al. Finding that AMOC collapse, contrary to the previous expectations that, well, it would make Northern Europe like Minnesota in the winter and Halifax in the summer, but it'll reduce the global average temperature a bit. They found actually no, it'll release some CO2, and it will probably increase temperatures by 0.2 C above everything else. But there is another point that they made in the paper that I'm wondering if you can comment about, that below 350 parts per million CO2, the freshwater forcing won't lead to collapse if it's turned off, if CO2 is below that threshold. But above that threshold, the freshwater forcing is strong enough, the AMOC won't come back once the forcing is removed. Does any of your work speak to that question? Because that's being described now as a tipping point in the AMOC, which it really isn't. And actually, it's good news in the sense that it argues, I think, and maybe you can comment on this as well, that SRM counterbalancing the radiated forcing back to 350 parts per million might bring back that reversibility.
Yeah, so this is a good question. So I've seen the paper, but I didn't went into that yet. So it's still on my reading list. So it's a little bit hard to comment on the specific on the specific questions you had. So I'm sorry that I can't answer all of them. But so maybe you can specify the question a little bit more. Because yeah, it's for me it's a little bit hard to comment on.
More generally, if we were, to suddenly gain the ability to do SRM, at whatever scale we wanted, and with whatever distribution we wanted, and we could also quickly do carbon dioxide removal, does that shift where we think the tipping points would be?
Yeah, so definitely that will shift where we are and how close we are, but I'm not sure whether that will shift it to that we are maybe moving closer or further away, because there is also a lot of evidence that you have like very stable AMOC states under extreme climate change, and maybe it is more related to the rate of forcing. So if you change or push the system really fast, that's what we're currently now doing, that's causing the AMOC to collapse. So that is, of course, something that people are now also trying to figure out. Like, if we are going to different kind of warming levels, will they shift the tipping point like further away or closer to the present day state? And there is also some evidence that if you are cooling the global climate, that you get a more sensitive AMOC.
Yeah, could you elaborate on that?
Yeah.
Sorry?
Say that last part again.
So if you are going to colder climates, you have a more sensitive AMOC, and that is also partly related due to sea ice feedbacks, that they can also be very large and they can also contribute to AMOC tipping.
You mean if we start cooling the planet, we'll have a more sensitive AMOC?
So what we see from other climate modeling studies in which they did like different kind of CO2 levels, and they looked at the AMOC in very long climate model simulations. So this is the group from Japan. They found like quite a more sensitive AMOC compared to higher CO2 levels. So that really suggests that also the background climate states does influence your AMOC. So these sea ice feedbacks, they can become quite large. That is also something we found in our climate model simulations, that sea ice really contributes to AMOC tipping. But now, of course, we're melting away the sea ice, so at least that feedback is getting less pronounced. So, but of course, we're also destabilizing the AMOC at the same time. So, at what we see with nowadays, we are moving to a different kind of equilibrium. So we are still in a transient. So it is now very hard to address this question: are we moving or closer to a tipping point? Well, probably we are under transient climate change. But if we do the warming at a very slow pace, maybe then we're also stabilizing the AMOC.
Is that why you said that melting the Antarctic ice sheet would save the AMOC? Or could?
So it could, but that is also on millennial timescales. So still you are reaching like a very weak state for like on a millennial timescale, and then eventually it does recover. So yeah, in some sense it is an AMOC recovery, but still you would be in a very weak state for a considerable amount of time.
So the cooling sensitivity is that specifically related to sea ice around the downwelling, the regions?
Yeah,
okay.
Exactly.
Okay, that starts to make more sense.
Okay. So let's go to some of the YouTube. And I went through here and I see a few.
Well, just on that last note, I wanted to put in the suggestion box, going south, our one of our regulars from Greenland would love to have you name drop the Greenland ice sheet when you get a chance, because he feels like it's fallen off the radar.
Greenland. Well, we don't
Yeah,
want it,
yeah.
we don't want it to fall off of Greenland. That's what we don't want.
Right.
No.
Yeah.
No, but I think also this question again, what is the hysteresis effect of the model when reversing the climate change and lower CO2 environment? This is something that people are exploring now. So we do always this hysteresis effect. So we're always adding fresh water, what we did with these kind of model experiments we did. But that is always done under pre-industrial conditions. But it would be very nice to do the same kind of experiments that with then, for example, with higher CO2 levels, that you can actually say something what the hysteresis curve would look like. Then we can definitely have a definite answer on that. But that is so computationally expensive. But we have this preprint out. You can read it, but I think it's for good for now to say it's nothing about it yet. But we are trying to indicate a little bit on this, on AMOC stability under very slow climate change.
And I should say hysteresis, by the way, is just the concept that you do something that causes the AMOC to collapse or anything to collapse, and then it doing the opposite doesn't bring it back. So there's a difference going in one direction than the other, and that's what hysteresis means.
Yeah.
And that's why it's a tipping point, because you can then stop the freshwater inflow. You can maybe freeze Greenland after we reach the tipping point, but then it won't matter anymore. And my understanding is because the AMOC brings it's a salt temperature-driven current, and it brings its own salt to the party. And so as it weakens, there's less salt, which weakens it, which means there's less salt, and boom, you get a collapse. But that might be oversimplifying a little bit.
No, but that's perfectly explained, Dan.
So I see a lot of these other questions are similar to what we've covered. So I want to kind of end maybe with one which is a little more personal, and that is you mentioned you have a new baby, and now they're going to be growing up. How does that impact the way you think about the world in general, and also, of course, your own research?
Yeah. No. Yeah.
And
so
where you
of
moved
course,
to?
and then well, probably the first few years I will stay in the Netherlands, and I don't expect to see any drastic changes in the upcoming 10 years or 20 years. Of course, that's also something we discussed. But probably in the upcoming years, we will still see some warming also over here due to the ongoing climate change. But of course, if I'm now saying like this is the risk of about 57% of hitting the tipping point before 2100, that is something I would not experience. Of course, I'm still an early career scientist. I'm 32 years old. But of course, for my newborn, or not my newborn, for my 1-year-old, this is something, of course, much more relevant. And therefore, I'm trying to reach a lot of people and to get this message across. And I hope that I can, of course, inform reporters, the broad public, but also policymakers that we need to really take some drastic actions such that we can lower this chance as much as possible, and that I hopefully can give my child, but also the new generation that is currently being born, that they have like a happy life with a steady AMOC.
Right, and then I guess the question to end with, and is this one we talked a little bit about, but what are you suggesting? Okay, to help bring this world to a steady AMOC, what are the basic tenets of that?
Yeah, so especially if we want to save the AMOC, we need to cut our emissions, and the technology is there. We know the solutions. We know that it is possible. But of course, the policymakers need to make some drastic actions on that, and that is something that current policies are not doing so, or not, or they need to step up their game, and they need to commit to the Paris Agreement, what was agreed upon 10 years ago. So they need to stick to the Paris Agreement,
which we blew right past. Right?
Hell yeah.
Stay below 1.5. Boom. That's where we are now. Headed to 2. By the way, 10 years from now, right? So
yeah,
or 11 or 12 years.
E-Conquest,
a little bit more.
He also mentioned something that is we talk about a lot, and this is totally a Leon thing. What about adding sulfur back to shipping fuels? Will that save more lives than we might lose with the AMOC collapsing?
Yeah, of course, that's also something that Leon touched upon is like what is now the effects of aerosols and the effects of greenhouse gas emissions? Can they compensate each other? Or which one is dominant? That is something also we don't know yet, but probably there is an effect. But we then need to design like very sophisticated studies to really study that effect to isolate both responses. There are a lot of people they have looked at that, but I'm not familiar with like all the details.
So can you give us, at the end with, a sneak preview of what your next paper is about?
Yeah, so our next preprint, so it is online on Archive, and there's what we argue is that climate change can indeed collapse the AMOC, but if you do it at a very slow pace, the AMOC will not collapse, even to like a very extreme climate.
I'm sorry. So if you warm the Earth very slowly,
at a very slow pace, like
the
10
opposite of
times
what we're
slower.
doing.
Yes. So if we do it at a pace that is like 10 times slower, we found like a climate for which the Earth continues to warm to like extreme levels, like beyond 5 degrees warming, but we are still having a stable AMOC.
And what do you think that tells us in practical terms? I mean,
Yeah. So if you do it faster, the AMOC will collapse. So that really suggests that the speed of the change, the speed of warming, that really determines whether your AMOC was shut down or not.
And we're doing this, and the speed versus the one that's stable. What we're doing now, you're saying we're changing it 10 times faster than that. Right?
Yes, exactly. So so that is of course a very idealized scenario again, but it is good to understand what drives now AMOC tipping.
Very good. All right. Well, good luck with that paper and all the future research. And thank you very much for joining us for a third time here on climate change. Again, it's very strange talking about these things when the rest of you go around your life and no one knows what it is, let alone talks about it. And yet this is something that's going to impact all our lives over time. But, 100 years from now, of course, I won't be around. Most of us won't be around. But our children and their children will be around, and it will be a very, very different world. And it's something that we let happen knowingly. And thanks for your research about the knowingly part. But anyway, thanks for what you're doing. It's great to have you on again. Good luck, and we look forward to having you on again when we talk about new research. And thanks everyone for joining. Don't forget to like and subscribe because this information is important. And the way it gets out there is by you liking, by subscribing, hit the notification bell, leave a comment. All of those kinds of things help spread the word. So thanks, everyone. And we will see you next time. Bye-bye.
Bye-bye.